In this video, we're going to take a look at section 2.3, which is on the topic of domain and range. So let's start with a couple of definitions. The domain is the set of all values that x is allowed to equal. So whether you're studying a graph, a relation, an equation, a table, whatever entity you're looking at, the domain would be the set of all values that x is allowed to equal. The range is the set of all values that it is possible for y to equal. So it's really the same concept, but for the y variable. The wording's a little bit different because the presumption here is that you are choosing values for x and then using the relation to get a corresponding value for y. But really the topics are the same, the concepts are the same. The domain and the range are the same idea, but the domain is for the x variable, the range is for the y variable. All right, so let's take a look at an example. All right, so for the graph, let's determine the following. First, for part A, it wants us to determine f of -3. All right, so if you remember from the previous section, from section 2.2, we talked about function notation, and this is telling me to use function f, which we have to presume is the graph we were given. Right, so this is the graph, function f over here. Right, this is f of x. And we're going to let x equal -3. Right? So whatever's in the parentheses, that is the number that's being plugged in for x. So I want to find this value of x in my graph. So the x value can be found along the x-axis. Right? So we look for -3 on the x-axis, which is right here. And then I look for a corresponding point with the same x-coordinate. So if I look up, I'll find this point here that has an x-coordinate of -3, right? And then I find the corresponding value for y given that particular x-coordinate. So this point here is the point -3. It has the right x value, and the y value is 4, which is what we're looking for, right? So remember, function notation is the y variable, right? So this thing is asking me to find y when x is equal to -3. And we are finding that y is equal to 4 in this graph when x is equal to -3. Now if we get a different graph, we'll have a different value for y when x is equal to -3. But for this particular graph, for this relation, when x is -3, the only possible corresponding value for y is 4. That's the only point that corresponds to that x-coordinate of -3. All right, so that's a little bit of a review of function notation from section 2.2, but applied in a different way, right? We hadn't really seen it used in this way in the previous section. Part B is what this section's about. So find the domain, which is the set of all values that it is possible for x to equal. So essentially, I want to find all the different x coordinates for all of these points in this particular graph. That's going to be my domain. So for part B, the domain is, well, what are the different values that we can have for x coordinates? We have this point here has an x-coordinate of -4, so -4 is in the domain. We already have seen -3 as an x-coordinate, so that should be in the domain. And we don't care about the y-coordinates for this. The domain only cares about what is it possible for x to equal. So here x can equal -2, right, for this particular point. For this point here, x is equal to -1, so that's another value in the domain. We have 0, right? So on the y-axis, x is equal to 0. That's another possible value. We have +1 and we have +2. So these are all the numbers that it is possible for x to equal, that x is allowed to equal based on the graph that we were given. And so we're just going to list those numbers out. Now it's important to understand that by listing these numbers specifically, we're saying nothing else works, including numbers less than -4. So those numbers are not in the domain. So -5 is not in the domain here, -6. Those numbers are not possible in this graph. They don't exist in this graph for x coordinates. We're also saying numbers bigger than 2 don't exist, right? So 3 is not a possible x coordinate in this graph. It just doesn't exist. There's no point here for that. But we're also saying the numbers in between the ones listed are also off limits, right? They are not part of the graph as well. So for example, -3.5, right, is not listed here because there's no point on this graph where x is equal to -3.5. So it's specifically just the numbers -4, -3, -2, -1, 0, 1, and 2, and nothing else. Just those, how many is that? Just those 7 numbers is all that it's possible for x to equal. Nothing else is allowed. So that's the domain. Let's take a look at part C. Find any x values for which f of x is equal to 4. Now this is flipping things around on us. They're not telling us what x is equal to. That's what we're being asked to find. What are the x values? What they're giving us is the y value, right? So y is equal to 4. And this is a little bit of a silly question because we already encountered that in part A. But it's asking for what are all the different values of x that give you a y value of 4 in this graph. So we find 4 on the y-axis, which we already have, it's right here, and look for any point where the y-coordinate is equal to 4. And we already have one here, which is this point here. This point has a y-coordinate of 4. The corresponding x-coordinate that goes with that is -3, right? So when x is equal to -3, that gives me a y value of 4. But we also have another point here with a y-coordinate of 4. It's this point here, which is 1, 4. And so when x is equal to 1, it's also possible for y to equal 4. So there's actually 2 answers for part C. There's 2 different x values for which the y-coordinate will be 4. And that is -3 and +1. So for part C, we'll have x equals -3 and x equals +1 as our 2 answers. All right. And then for part D, we want to find the range, which is the same idea as the domain, except it's asking, what are all the possible y values? Sorry, I'm having trouble writing here all of a sudden for some reason. Let's try that again. All right. So the range here is asking, what are all the different possible y coordinates that occur in this graph? So we want to list all the different y coordinates for these points here. So we'll start from the bottom. We have the lowest y coordinate is 2. And then we have 3, which occurs twice. We have 2 different points with a y coordinate of 3, but we only need to write 3 once in our range. We have 2 different points with a y coordinate of 4, but we'll just write 4 once in our range. And then we have 5 as another possible y coordinate. And that's it. These are all the different values that it's possible for y to equal in this graph. There's no points here with a y coordinate of 6. There's no points here with a y coordinate of 1. There's no points here with a y coordinate of 2.5 or 3.1 or any number in between. It's specifically just the numbers 2, 3, 4, and 5. That's the only numbers that it's possible for y to equal in this graph. All right, so that's how the range works. I hope that kind of makes sense. It's kind of I think students understand the concept of what the domain and range is about, but applying it to different graphs and different equations is pretty difficult. It's a difficult task. A lot of students have trouble with that. So let's take a look at another example here. So we have another graph, except this time it's not just individual points, it's an entire continuous line. In fact, it's a V shape, right? So part A starts off the same way. It's asking for f of 3. So remember what we said about this last time. This is the y value, or the y coordinate, when x is equal to 3, right? So whatever they have in the parentheses, that's what we want to set x equal to. And then because they're asking me to find the function value, they're asking me to find the y value, the y coordinate. So I go to my x-axis, I look for 3 on the x-axis, which is right here. And then I look on the graph for any points that line up with x equals 3. And I get this point here. Right, so this point on the graph has an x-coordinate of 3. It's the point 3, 2. And what I want from that is the y-coordinate. Right? They're telling me x is equal to 3. I find that here. And then from that, I get this point. And then from that point, I get a corresponding y value of 2. Right? That's the y-coordinate that goes along with the x-coordinate of 3. And so that's the answer to this question, right? You want the y-coordinate for that. Okay, so that's part A. Part B, we want to find the domain again, which means we want all the possible values for all the x-coordinates, right? What is it possible for x to equal? What are all the different x-coordinates that occur in this graph? Now, it's important to note that on the end of this graph, we have an arrow, which indicates that it doesn't stop here. It keeps going up and to the left forever, and up and to the right forever. So if you ask, well, what are all the different x coordinates that we get on this graph? anything. Any value of x will at one point be an x coordinate somewhere on this graph. When x is equal to 0, we get this point here. When x is equal to -2, we get this point here. When x is equal to -4, we have this point. Right? So any value that you could choose for x, there is a corresponding point on the graph with that particular x coordinate. So any value of x will eventually show up somewhere on this graph. So when we start getting graphs like this, I think the easiest way to find the domain, so I'm just going to kind of break it down for you and tell you just the easy way to get the answer. It doesn't work so well on this situation where you have just specific points. But if you have a continuous line like this, to find the domain, all you have to do is ask yourself, how far to the left does the graph go? How far to the right does the graph go? And that's going to tell you the possible values for x. This graph goes forever to the left, which means it's going to go to -infinity. It just keeps going forever to the left. And it goes forever to the right. So it goes to +infinity. So my domain in this case is going to be from -infinity to +infinity. All right, so that's part B. The domain is -infinity to +infinity, which in other words is all real numbers. Any number goes for x. Every value of x is allowed. There's nothing that isn't allowed. I don't know how else to say it. You can pick any number you want for x and it's fine. This graph has a home for every value of x. Maybe that's a good way to put it. All right. So -infinity to +infinity. Now let's take a look at C, which is similar to the problem that we saw, similar to the question that was asked in the previous example. Find any values of x for which f of x is equal to 2. Right? So if they're telling me, I don't know why it keeps doing that, it's telling me f of x is equal to 2, which is telling me the y value, right? F of x is the y value. So y is equal to 2, and when y is equal to 2, we want to find what are the corresponding values for x given that y coordinate. So we're going to find y equals 2 on the y-axis, which is right here, and look for any point on this graph that has that particular y coordinate. And we see that it lines up with two different points. We have this point here, but you got to look further down to the right. There's another point where the y coordinate will also be 2. So we get this point that we already encountered earlier, which is 3, 2. That has a y coordinate of 2. But we also have this point here, which looks like it's at 7, 2. And that also has a y coordinate of 2. So we want to find all the different x coordinates that have a y coordinate of 2. There's 2 of them. There is this one here where the x coordinate is 3. And then there's this one here where the x coordinate is 7. And so those are the two answers for part C. X could equal 3 or it could equal 7. Both of those give me a y coordinate of 2, which is what part C is asking for. And then part D is asking what's the range for this graph. And again, the range is asking what are all the different possible y coordinates that exist on this graph. And so the y values run vertical. They run up and down. So it's very similar to the domain. We want to know, what's the lowest y coordinate we can get? What's the highest y coordinate we can get? And if we look at this graph, the lowest it goes is this point right here, which has a y coordinate of 0, right? That's the low point on the graph. There are no y coordinates on this graph that are negative. There's no points where y is equal to -4 or y is equal to -6. So those numbers do not belong in our range. It only goes as low as 0, but it goes up forever, right? Because the graph keeps going up as it goes to the left, keeps going up as it goes to the right. So it'll just keep going up forever, but it does bottom out at 0 for y. So again, the easy way to find the range, I'm trying to explain the concept, but if you want me to just break it down into a rule for you to follow, it is you want to ask yourself, how far down does the graph go? How far up does the graph go? That's how you get the range. Right. How far down does it go? Well, it only goes as low as 0 on the x-axis. That's the lowest y coordinate we can get. How far up does it go? Goes up forever. So that's +infinity. So the range would be, why is it doing this to me now? The range would be from 0 to infinity, and including the 0, right? It reaches 0, so we use a bracket on the 0. Right? We learned about interval notation in chapter 1. We didn't use it as much as I would have liked in chapter 1, but for domain and range, it gets very heavily used. So you're going to want to, make sure you get comfortable using the interval notation and remembering what it means to use parentheses versus brackets. Okay, let's take a look at the next example. So the first couple of problems you're going to be given on the homework for domain and range will be graphs. And so we just did those examples. And there's a few of those. This section's not very long. There's not a whole lot of problems. The second half of the homework assignment is going to be giving you an equation or a function like this and only asking you to find the domain, because we haven't really talked enough about these types of equations for you to be able to figure out the range. The range is going to be a little bit more difficult. So only find the domain of this function. Now, whenever they ask you to find the domain, the first question you should ask yourself is, are there any limitations to this equation? If there's limitations in the equation, that will often limit what you're allowed to plug in for x. So are there any limitations in this equation? So start off assuming that the domain is all real numbers. I can plug in any number I want. And then ask yourself this question. Are there any limitations in this equation? And if you find a limitation in the equation, determine if that means there's a certain value of x that you cannot use in the equation because of that limitation. And if so, remove it from the domain. So start with the assumption that it's all real numbers, and then remove any values that you're not allowed to use because of the limitations in the equation. And whatever you're left with will be your domain. Right? So what's going on with this equation, the limitation that exists is the denominator. And I don't know if we've talked about this yet in this course, but something that is not okay is you cannot divide by 0. That is a limitation. In math, you just can't divide by 0. It's a limitation of mathematics, and that's a limitation that we need to be aware of for this kind of equation, because I don't want to plug a number in for x where I'm dividing by 0, because then it just doesn't work. The equation breaks. So what number should I avoid using here so that I'm not dividing by 0? A lot of students will answer that with the number 0. Don't plug in 0 into this equation. But if you plug in 0, it's fine, right? Plug in x equals 0. You get f of 0 equals 10 over 0 minus 5, which is 10 over negative 5, which is negative 2. Right? No problems there, right? The equation handles that just fine. The number that it doesn't handle just fine is the number 5. So maybe you figured that out already. If you plug in 5 for x, you'll get 10 over 5 minus 5, which gives me 10 divided by 0, but I can't divide by 0. This is just an undefined value. It doesn't produce anything. It doesn't equal anything. It just breaks. Like the equation just does not continue any further to give us a result. And so we should avoid using x equals 5 in this equation because it breaks down the equation, right? It doesn't, I don't know how to say it. I can't find the right words to describe it, but the equation does not successfully resolve when we plug 5 in for x. It successfully resolves for any other number except for the number 5, because then we're dividing by 0 if we plug that number in. And you can't divide by 0. So my domain, again, I start with the assumption that it's all real numbers, but now I realize, well, this doesn't work, so x should not equal 5. Right? I can't plug in 5 to this equation. So I need to remove that number from my domain, but I'll leave everything else there because everything else should be fine. And so my domain is going to be all real numbers except for the number 5. That's the only number I need to omit. And that's going to be option B here. So the notation here reads, the domain is the set of any number x such that x is a real number, so any real number you want, as long as it's not equal to 5. Right? X cannot equal 5. And that's the statement that we want to make. Now for the second example that I've squeezed down here at the bottom of the screen, we ask ourselves the same question. Let's start with the assumption that the domain is all real numbers, and then ask ourselves, are there any limitations in this equation? Do I have to worry about dividing by 0? No, because there's no division going on in this problem, so I don't have to worry about dividing by 0. That's not a limitation here. And the only other limitation that you really need to be aware of at this point that you're not even going to see in section 2.3, but I still think you should be aware of it, is you cannot take the square root of a negative number. At least that doesn't resolve to another real number. You know, if you take the square root of a negative, it comes out imaginary, and that's something that you sometimes want to avoid. So you can't divide by 0. You can't take the square root of a negative number. Those are the only two limitations that you should be aware of at this point. And if the equation doesn't exhibit any of those limitations, then there are no limitations. So for this equation, for this function, there are no limitations. I can't divide by 0 because there's no fraction here to cause that division. There's no square root, so I don't have to worry about the square root of a negative. So this equation has no limitations, which means the domain is just all real numbers. There's no number I need to omit because there's no limitations in that equation. Right, so that's how I would determine the domain for these problems. Right, and like I said, the range isn't even a question for these problems. All right, so let's take a look at another example. Find the domain of this function. So we're back to having a fraction. So what's the limitation that we have to be worried about? We have to be worried about dividing by 0. This denominator cannot equal 0. That's the limitation that I have to worry about. But the difficulty with this problem is, when will it equal 0? What number should I not plug in because it would make my denominator equal 0? There's not a simple answer here because it's a complicated expression. So when would this equal 0? I can't tell just by looking at it. So what you have to do for this one is calculate it. So here's what's not allowed to happen, right? And I like to give it this heading so that I don't forget what I'm looking at, right? So here's what I don't want to see. I don't want 4 minus 7x to give me a result of 0. That's the thing I want to avoid, right? So this is the thing that's not allowed to happen. And by setting that up, I can investigate to find out, well, what value of x is not allowed to exist, right? What value should x not equal? And I can find that out by solving this as an equation. So this is the equation that's not allowed to happen. Solve that to find the value of x that's not allowed to happen, right? And so we'll start by subtracting the 4 to the other side. We get negative 7x is equal to negative 4. And then to solve for x, we divide by negative 7 on both sides. Now, as a fraction, this doesn't reduce, but the negatives cancel each other out, right? So negative divided by negative will be positive. So we'll just get 4 over 7. And remember, this is what's not allowed to happen. X is not allowed to equal 4 over 7. That's the one number I have to avoid using in this equation because it would make 4 minus 7x equals 0. And if that's equal to 0, I'm dividing by 0, and that's not okay, right? So the domain is going to be any number you want except the number 4 over 7. That's the one number you cannot use. And so the statement here that corresponds to what I just said is B, right? X can be any real number except 4 over 7. That's the one number you can't use. All right. So why don't you give these problems a try? This is kind of weird. So this didn't copy over very well, but there should be a fraction bar there, I believe. So pause the video for a moment. See if you can determine the domain of these two equations. And once you've come up with what you think is the correct answer, resume the video to see if you had the right idea. All right, so in this first equation, this has no limitations. We're back to the only limitations you have to be aware of is you can't divide by 0. Not an issue here because there's no division going on. It's not a fraction. And you can't take the square root of a negative, which, like I already mentioned, you're not even going to encounter. So you almost don't have to worry about that one. So if you're not dividing by 0, there's no limitations. So the domain is just all real numbers. So you should have picked, for the first equation, even though it's an absolute value, you can plug any number you want into the absolute value. The equation can handle it. There's no situation that we have to avoid. So any number works. This one, you have to be careful not to divide by 0. So you actually do have a limitation here. The limitation is that 9 minus 2x cannot equal 0. So what number do we have to avoid plugging in for x? We will set this up. This is what's not allowed to happen. And so we'll solve that for x to find out what x is not allowed to equal. So we will subtract 9 from both sides. We get negative 2x is equal to negative 9. Divide by negative 2 on both sides. We get x is equal to 9 halves, right? The negatives cancel each other out. We get x is 9 halves. This is what's not allowed to happen. So x is not allowed to equal 9 halves. But x can equal anything else. Any other number this equation can handle except the number 9 halves because it would make us divide by 0. So the correct choice here is option C, right? X can be any real number you want, but not 9 halves. That's the only one you can't pick. All right, so this concludes section 2.3 on domain and range.